Alrighty folks, so you went and got 2, 3, 5, 10 estimates on having your foundation fixed and got them all spread out all over the kitchen table, and this guy's got concrete piers, this guy's got steel piers, this guy's got helicals, this guy's got bell bottoms. You got all these different kinds of piers on them that you've been offered, and everybody says their pier is the best. So just one thing that we like at CoreTech is transparency. We want you, the homeowner, to have or to be armed with the best information, the most information you can have. And what that does is the better information you have, the better decision you can make for you. And we want you to make the best decision for you. I don't want you to make the best decision for me. I mean, you know, we're here to help you. You're not here to help us. So this video, we're going to go over the different kinds of pilings, the most commonly found pilings on the market, and what their uses are, what their pros and cons are, and that way maybe you can gain a little bit better understanding. So stick around, we're going to jump into it. Okay, let's start off with concrete press pilings. This is good old reliable. You know, this is the most commonly installed pile on the market. Let's go through history, you know, travel back in time. And let's start about 1900. You've got segue of different construction methods. We went from wooden houses with wooden posts to wooden houses on concrete piers to wooden houses with concrete perimeter footings, right? And then the concrete footings got real popular and somebody said, hey, why don't we build a house completely out of concrete, you know, foundation completely out of concrete. And that's more than likely what you're gonna witness today is concrete slab on grade foundations when you look at new modern construction. So let's go back to the year 1941. And if you paid attention to history class, you would know that the biggest world event in the year 1941 was World War II. The efforts to support the war required a lot of steel, right? From aircraft carriers to destroyers to submarines to tanks and bombs and guns and just all the stuff that you got to build for wars, trucks and jeeps and all the stuff you need to build tools for war. So our steel supply, our ability to manufacture steel was 100% allocated to war efforts. If you know anything about concrete, concrete is a fantastic thing, but concrete cannot survive without steel. You gotta have some steel reinforcements. And for just to condense this, you have to have some kind of a skeletal structure. We're just gonna put it, there's more to it than that, but you know, the concrete has to have some kind of a skeletal structure internally to bond to. So let's start about 1950 and work our way up. From the year 1950 to the year 1980 is about 30 years, right? If I can count. That's a good enough amount of time for things to start moving around. So, you know, about 1950 or so is when we started seeing the proliferation of concrete slab on grade foundations, which is why we're going to use a piling. You know, forget about the wood houses right now. Let's talk about slab houses. When we were faced with the issue that these concrete slab houses were starting to move, we were faced with the new solutions that started coming out. And obviously, you know, we had to put something in the dirt to be able to support that foundation and raise it back into order. Pilings or repair pilings were born at that point. The first patented repair piling, well, that's in common use today, is a concrete press piling, and it was called the PermaPile system. And so what that was a cylindrical piece of concrete, and they actually started out as core samples because there was a bunch of core samples left over, and they said, hey, why don't we just try these? We got a bunch of them laying around, let's test it with this. And they were driven into the ground using a hydraulic press, one after the other, after the other, after the other, until they hit refusal, and then they could lift and stabilize the house. It's extremely simple, extremely effective, and that's why it was the base for what is our industry today. Obviously, you know, when we build something, we're always looking for the bigger, better mousetrap, right? So, you know, the Ford Model T is obviously where modern automobiles came from. But when you look at a Ford F-150 that's, you know, brand new at the dealership right now, it's much better than a Ford Model T. So things progress naturally over time. The foundation repair pilings are no different, but you know, there's only so complex you need to make a system. And this is where we're gonna get into the branch to other systems. We as human beings are always looking for the next best thing. How do we improve? So there have been some improvements on the press piling, but typically when we look at concrete press pilings, the improvements have been in the installation methods, and that's really the only place you can improve that pile. In a nutshell, what a concrete press piling does, or what its function is, it's to gain support so that we can lift and permanently or long-term, I don't like using the word permanent, nothing on this planet's permanent, long-term stabilize the house. And that's what we put lifetime warranties on. And it doesn't matter if it's me or XYZ or ABC or 123 Foundation Repair, whoever, the common practice is lifetime warranties on a press pile. The reason that works is because the amount of resistance or amount of force used to drive this piling in the ground, and I'm going to try not to sing the technical lullaby and put everybody to sleep, but that amount of force is going to equal resistance long term. You have a little delta there where you are going to see some subsides or some loss in resistance, but the idea is we want to provide more resistance than we have load. Load being the weight of the building that we're supporting. As long as we have enough pilings, we have enough resistance, we have the piles spaced close enough together to where we're not overstressing the foundation beams, everything is going to be just fine. Now, let's talk about steel. We're going to segue into steel pilings. Steel pilings were invented to circumnavigate the soil conditions that are not conducive to good concrete press piling installation. Here's an improvement. Now, that does not mean that steel pilings are bar none better than concrete press piling. Every tool in your toolbox has a job. A screwdriver is not real good at putting in nails, a hammer's not real good at putting in screws, and vice versa. You have to ask yourself, what is the context of what I'm doing? Why am I using this thing for my particular application? Steel pilings have a much smaller diameter than a concrete cylinder. Typical concrete cylinder is a 6-inch in diameter cylinder. A steel piling is usually 2 7/8. And the reason you can make it smaller in diameter is because the compressive strength of steel is much greater than the compressive strength of cast concrete. And they're also more resistant to impacts or point loading, which point loading is if you have kids and you've ever walked across the floor barefoot and you step on a Lego, you've point loaded your foot and that's why it hurts like hell. I got 6 of them. I've stepped on plenty Legos and Barbie shoes in my life. I know what pain feels like. When we have rocky substrate, things like that, concrete press pilings are really at a disadvantage because of the point loading, and the steel is more resistant to that point loading, therefore it's better in a rocky substrate or in a rocky kind of environment. The other thing with rocky environments is usually when you have rock, you have sand. I mean, sometimes you have clay, but by and large, rock and sand are kind of go together, and clay is sort of on its own thing. And we don't live in a world where we have hard boundary lines between soil classifications. It's kind of just one big gumbo mix of stuff. That's why we call our soil gumbo. The implementation of a steel press piling is going to be best suited for soil that is either got lower plasticity indices, greater abrasion, and higher density than other soils. So if you're in a sandy area, let's say you're in Magnolia, you're in Tomball, let's say you're in some of the areas that are up and down the San Jacinto River, right, where you get a lot of sandbanks. Putting a concrete press piling there is the wrong thing to do because you're going to come back in 3, 4, 5 years because that piling is going to have sunk. I remember being on a job in somewhere Magnolia, Tomball, kind of up 99 area, and we went to go put a concrete pier in and pushed the button, and it immediately jumped to refusal. House started coming out of the ground. I mean, it was one cylinder that we drove in the ground, maybe halfway. And so when we get no depth on our pilings, yeah, it might work for now, but it's going to fail. It's more prone to failure sooner than something where if I get better depth in the ground. We'll get back to that in a minute. We're talking about soil here. Let's talk about sand for just a minute. Like, you're not putting a press piling in Florida. You ain't doing it. It's just too sandy there. It is too compact there. It's not happening. You need to put a helical in if you're in Florida. We are not in Florida. We're in Texas. We're in Houston, greater Houston area. So, everywhere is a little bit different. If you ever run your hand across sandpaper, it's very abrasive. Well, sandpaper came from somewhere. It's not made from sand, but it is abrasive like sand is. When we drive press pilings in the ground, we are counting on a couple different things. One, we're counting on the density of the soil, allowing us to push the piling into the ground. We're counting on the friction of the soil to hold that piling in place. Here's kind of a foundation repair myth, right? There's a lot of guys, and I've seen this kind of die off. I haven't heard it much, but I do hear it every once in a while where somebody goes, oh, you're gonna push down to bedrock. No, you're not. Not here. This isn't the Flintstones, and this is not Austin, Texas. So, when we have quote unquote bedrock, it's not accessible here. It's here, it's just, I mean, it's a couple thousand foot in the ground, and I don't know about you, but I'm not driving a 2,000 foot piling. So it's quite literally like a nail in a piece of wood. The nail is held in the wood by the friction of the medium, which is wood, that's applied to the shank of the nail. So if you can think of a press piling like a nail, we want to drive it into the ground, and we want enough friction around it to hold it in place. You know, that's where press pilings, going back to the concrete piers, are largely successful, because Houston and its surrounding areas are largely made up of clay substrates. So we can get enough depth to get enough surface area contact between the shaft of the pile and the dirt that surrounds it to create a friction bond that has enough resistance to raise and stabilize your house. Now, if you ask me to put a concrete press piling in on your house at Tomball, I'm gonna say no, absolutely not. If you ask me to put a steel piling in your house in Sugarland, I'll do it, you're just gonna pay a lot of money for it. So, you know, that's kind of the difference between the two. They're both equally effective tools when used in the right application. I wasn't born in the 70s, but I love bell bottoms, okay? Bell bottom pilings to me are absolutely 100% the best piling on the market. But Eric needs to put a bunch of asterisks and red flags and stuff in here, because although I think they're the best piling in the market, that's not what I recommend for most foundation repairs. The birth of a bell bottom piling is going to be, well, let's just go to the most common uses. Yeah, you have casings and under reams that you put in for bridges and for big skyscrapers and things like that. That's great. But residential construction sense, the birth of the bell bottom pilings were an upgrade to a typical slab foundation that you could do to help prevent stability or help promote stability long term. But from a repair perspective, bell bottoms to me are performance-wise the best way to go. Is because you don't have to use the house as resistance. The problem is when we go out to estimate something, I guess we could, but we probably get 2 estimates a year. We can't charge money for that estimate. The industry has mandated that free estimates are the norm. To design a good bell bottom piling, we need to do core samples, maybe like a 3-bore, 2-bore, 2-bore sample is probably good enough for a single lot. You need to do a geotechnical lab analysis. A geotechnical structural engineer needs to determine the bearing capacity, plasticity indices, abrasion, compactability, a whole bunch of different factors as to what is in the ground underneath your house. And then we need to look at the house. Is it a 1-story, 2-story? Is it one of them funny 3-story things that's real narrow? I mean, what are the load implications that the house is putting on the ground, and what load do I need to overcome? So when we look at all of these factors, we got to do all this stuff to be able to design a proper functioning and effective bell bottom piling. When you do all that stuff, it costs money. And so if I were to tell you that I put bell bottom piles in because they're my favorite piling to put in, because from a performance standpoint, they're the best performing thing, but your estimate's going to cost you $7,000, you're going to laugh at me. And so that's where we go back to the use of press pilings. I don't have to do all that engineering investigation before I go design a press piling. We're going back to using the pile that's going to be driven into the ground. It's going to travel as far as the soil and the load of the structure are going to mandate. But what a bell bottom pier is, you take an auger, you drill it into the ground, you pull the auger out, then you send a belling tool that flares out and opens up and creates a shaft with a bell at the bottom. And so that's, from a design perspective, I mean, it's great, it's fantastic. But the next thing is I've got to have this auger that goes in the ground. If I need to put a piling on the on the inside of your house, let's say the exterior does a little bit of movement, but the interior does too, how am I gonna get this giant ass auger into the inside of the house? I mean, it's either very disruptive or sometimes impossible to do. And so, you know, the practical application of putting bell bottoms in, you've got some limitations to what you can actually do. Let's segue into helicals. Helicals are another favorite of mine for new construction. And because you can put them in really fast, you don't have to, the dry time, there's no dry time there. When you pour a bell bottom, you got to wait, you know, at least 21 days for the concrete to set up before you can put any real load on them. Helicals, on the other hand, you screw them in and you move on to the next one, you're done. And that's great. What a helical piling is, you have a pile shaft that's usually 2.5, 3 inches in diameter, and you have a blade on the bottom of it. Looks kind of like a corkscrew. And the way they're installed, they're quite literally screwed into the ground. It's like a big giant bolt that you're gonna thread down into the dirt. And I got suckered into doing some helical installs on some new construction, and it was great because I'd go me and a helper. And then when I got 2 helpers, it was even faster because I had one guy stacking, one guy helping me, and I was running an excavator doing the work. We could put 40 pilings in before lunch, and then we'd go get a beer or something. So from an install perspective, helicals on new construction, man, you can put them in fast. I mean, really fast. As a matter of fact, to drive a helical 25 or 30 feet, I mean, it takes about 30 minutes, right? And so depending on the soil type and whatnot, I mean, you can really get them in quick. Especially if I had 2 guys running, man, it was 2 machines running. I mean, we could really get them in fast. I think that's it. I think that's the future of engineered slab foundations. I think the future of engineered slab foundations are going to be helical piles. From a repair perspective, the same troubles that you face with a bell bottom, you're going to face with a helical. You've got to design it to the proper depths for the load application that you're going to be supporting. And you have to figure out how to get this equipment where you need to get it. Think about it. I mean, you don't drive a helical piling with a portable machine. I mean, it's portable, but it's portable like it goes on a trailer. If you've ever seen a mini excavator or a skid steer, they're kind of big, and so getting that in and out of your yard might be kind of difficult. And certainly if I had to put a piling somewhere in the inside of the structure, I guess anything's possible, but it might be a little too cumbersome. Me, in my personal opinion, you know what they say about opinions, everyone's got one, and the rest of the saying, I'm always circling back to press pilings. As much as I like the other products, circling back to press pilings. Now, there are some wild card piles that I've seen, and I don't want to call anybody out by name, but I've seen some that were kind of goofy. And even in my marriage I didn't marry into CoreTech. I married my wife, and I got kind of drug into CoreTech. But in my integration with CoreTech, we had this question: can we design something that is going to compete with other people's better mousetraps? And I spent some time at the drawing board trying to design a thing that we could implement and patent to give us an actual performance advantage. The thing is, you got to spend this much money to get this much performance advantage. And at the end of the day, to us and to me, it just wasn't worth it. There are some new players in town that are promoting some very interesting products. And really and I'm not trying to cut these guys down. I like innovation and I like technological advancements. I'm all for that. But looking at some of the things that are being promoted, there's only one reason I think that they're being touted as much as they are. It's to give themselves some kind of advantage to attract buyers to spend money with their organizations as opposed to somebody else. They're giving themselves a performance advantage, maybe not necessarily in the repair aspect, but in the marketing and sales aspect. This might be a little bit of a cheap shot, but our performance advantage is transparency. We just want to be transparent with you guys. We want to tell you guys, hey, this is the reality of things. When you go to your doctor, you don't want him to go, well, you can beat around the bush. No, doc, tell me what's going on. Am I going to die or not? And so that's kind of where we are. One of my biggest strengths, but also one of my greatest weaknesses is the fact that I've got like zero filter from here to here. Whenever I think something, it just falls out. Fortunately, I think I've got enough, I feel like I've got your best interest in mind. So when I say things to you, either on the camera or if I meet you at your house, what rattles around my head just falls out. And because I have your best interest in mind, and because I think I've amassed a lot of experience in this industry, usually that translates to, hey, I'm trying to do the best thing for you. And sometimes, it might be the best thing for the situation. It might not be the best financial thing for you. Remember, I'm not a financial planner. I'm a structural advisor. So, you just have to take that with a grain of sand. What application are you asking me to come give you advice on? So we've talked about a handful of pilings, and we've talked about some outliers. We don't want to take this and turn it into an hour-long college course on substrate support, okay? Matter of fact, half of you probably already got bored and went and found a cute cat video to watch, but here's the bottom line. When we are designing something, and I work with engineers a lot. I personally am not an engineer. I've got an engineering background. I've got some engineering studies under my belt, but I cannot come out and tell you that I'm an engineer. One of these days I'm going to be able to say that, but today is not that day. When we design something, it doesn't matter if it's a beam, if it's a rafter, if it's a truss, if it's a piling, if it's a whatever thing we design. The simpler the design, typically the more reliable something is. And the more complex the design is, the more moving pieces you have, the more things that can individually fail. And so, once again, I might be over here pimping pressed pilings, but the thing is, they're simple. And you ever hear the old saying, KISS, K-I-S-S, keep it simple, stupid? Well, we try to keep it simple. And sometimes we call ourselves stupid. But the premise is, if you're going to design a structural component, the simplest design to me is going to be the most effective. And the only time we need to complicate the design is if we have some weird outside factor where the simple design is not going to work. And usually in a structural sense, that's pretty thin. That's a pretty thin layer of things you got to work through. If you're looking at civil design or fluency or conveyance or something like that, yeah, things get kind of tricky there depending on the lay of the land. But from a structural perspective, support perspective, most solutions are pretty simple. So we want to keep things simple. We want to just put good repairs in. We want to make sure that things are going to function long-term for you. And that's the only thing that anybody should be looking for when it comes to a structural repair. So if you're in the weeds and you want an honest to God, clear, concise, non-biased opinion, I mean, yeah, I guess I got a little bias. I want you to do business with us. But really, if you're looking for some actual clarity on what you're dealing with and how to overcome those problems, do yourself a favor, click the link or push the call now button or whatever. I mean, my guy Eric behind the camera, he's going to put something in here for you to call us, and we'll come out and give you an honest, clear, concise opinion of what's going on with your problem and what our solution is for that. So the last thing is, please do us a favor, leave a comment, like, share, subscribe, all that stuff. I'm supposed to say that in these videos, and I'll be honest, I've been kind of lazy on saying it. So here I am, putting my 2 cents in. Do us all a favor, and if you would, just click the like and subscribe and the little bell thing or whatever all the famous YouTube guys say. So, hey, thanks a bunch.